Okay, part 2 of my video introduction and review to the Extech model LCR200. I didn't really cover adequately the percent relative function and the sorting function, so I'm going to try to do that here. The instructions in the manuals are a little bit vague. They kind of lead you in the right direction, but I tried getting Extech to provide something better, and they were just kind of like deer in the headlights. They insisted the manual was perfect, and obviously they didn't really know how to use it themselves. Anyway, so I thought I'd just mess around with it here and see if I could demonstrate it a little bit. So I'm trying to get this camera and the meter at an angle where I don't get too much reflection. So this first function is the relative, or REL/percent function. So I guess, I don't know if rel means relative or something else, but it's a percent difference function between a baseline standard. So let's try the rel/percent function, and the first thing to do is establish a baseline. And apparently it's important. I haven't verified this completely in an empirical fashion, but the instructions do seem to suggest that using the rel/percent function or the sorting function, the meter needs to be manually set up. So I'd actually gone here and pushed the LCR button until it was forced to capacitance value instead of auto detecting, and I specified the frequency to 1 kilohertz. It would have defaulted to that, but I made sure it was at 1 kilohertz, and I also specified that it was going to be looking at the dissipation value, but apparently that is not, that's a secondary value, and it looks like the meter does not evaluate that for this comparison. It only looks at the primary value. And so really all I've done is made sure I stipulated the frequency and that I'm looking at a capacitor. So now I go and put in, okay, so I got the capacitor in there and it's reading 22.22. It was 22.23, and I actually jotted that number down. Now it's rolled over to 22.22. And to establish this as the baseline, I just need to press the rel% button until it chirps and puts a diamond, or a triangle rather, up in the upper right hand corner. There. And you notice the secondary display has shifted to read percent now, and this indication tells me that now it's reading component values and calculating a percentage deviation from this value. I should point out that in this video I'm not using the same meter that was in the first one, because since doing that one I returned it. The battery holder screw was something they weren't prepared to replace, and they said that I wouldn't have the same problem with the spring clips here being too tight if I got a different one. Of course they didn't really know that, but that's what they asserted at Extech. So this is the replacement unit, and I've already got the baseline established. Now I'm trying to stick the component lead in here. I'm just kind of putting in there and wiggling it around and hoping for the best, because just pushing it in straight, it just bends like that. And it's just extremely difficult to get the leads to poke in there. Okay, I managed to get it in there, but I had to use my needle nose pliers to hold the leads. Okay, so this is now reacting to the base reference value, and the first value, the reference value, is 22.23 nanofarads. This one's coming in at 22.17, which it says is a minus 0.3% deviation. And I should notice that the bar graph down here, which I assumed would read percentage, seems to be reading a constant 5% out of 100%. I have no idea what that means, but we'll pay attention to what it does in the readings here. Now, to do a little verification, get my trusty calculator here, and the original base value was 22.23, and this meter here is saying minus 0.3%. So I'm going to say minus 0.3, and the percent function is a second function, so I have to push the green button, then percent, and then hit equals, and it's 22.16 is what that would be. 22.16. So it is giving me an appropriate percentage deviation from the baseline value. Let's try another capacitor. Okay, the second one is in. I was actually able to get one in by my hand, and the other one I had to use the needle nose on. It's reading 22.68, and it says that's a 1.9%. That's a positive value, 1.9%. So I'm going to go back to my calculator. I'm going to put in the base value of 22.23 and go plus 1.9% and hit the equal key, and it's saying that should be 22.65. Close. This really should be something with an extra decimal point to get that close, but it's certainly within one digit of the closest resolution. So that worked. Notice that it still says 5% here. I think this is meaningless. Well, this meter is definitely better than the first one. I was able to get this one in with my hands alone, but it's very tricky. If you don't get the angle just right and everything, it won't slip in there and the leads will just bend. So it's still far from what it should be. But on the other one, I could not get the leads to go in at all, or at least hardly ever, even using the needle nose pliers every time. So this is an improvement, but it's still far from what it should be. So this last capacitor is reading at minus 0.8%. Which is a 22.03 nanofarad value. So remembering that my baseline value was 22.23, entered that, I'm going to go minus 0.8% and then hit equal, and that's a 22.05 value, which is pretty close to the 22.03 it's actually reading. I'm sure that's due to an extra decimal point of percentage, that's a percentage deviation that's not being displayed here. The point being that it's in the ballpark, and this is just allowing you to see how different components vary from the base level, and obviously it's only one decimal point of resolution there, so it's not going to be spot on. But that function does seem to work. And then to cancel out that baseline from memory, all I need to do is push the rel button and hold it for a couple seconds. And remember that this diamond here means it's in that mode. So if I push it for a couple seconds and hold it, it clears it out. Now it's back into normal operation. I want to try one more thing with the relative percent mode. I'm trying to figure out what this bar graph does. Now I have, if I can find them here, I've got 4 orange drop capacitors that all look the same, but 3 of them have the same value and the 4th one has a completely different value. So that might get this percent to swing around a bit more. I'm going to try that. Okay, so we're back in auto mode. I'm going to force it to go into, or I'm sorry, it isn't in auto capacitance or LCR mode. It's in auto CP mode, which is what I want. So now I'm going to plug in my reference capacitor. And this one has stiffer leads. It might actually go in to these a little better. Let's see. But they're also fatter. Maybe it won't. Oh yeah, it did. This one went in a little better. But these clips are hell on the smaller component leads, which is really what most of them are these days, unless it's a power component or something. So this is reading, this is also a 22 nanofarad part. This one's reading at 21.93. So I'm going to push the relative percent button until I get the diamond up in the display. And the manual says you have to hold it for 2 seconds. I found that if I hold it for 2 seconds, nothing happens. You just have to push it meaningfully and release it, and that does the trick. And the same thing goes for canceling functions, by the way. If you're either in the relative percent mode or the sort mode, the instructions say to hold down either the one button or the other to cancel that mode, and it says you have to do it for greater than 2 seconds. That does not work. If you hold it down that long, nothing ever happens. You just have to, again, push it down more than the slightest tap and release it, and it does the trick. Anyway, so it's memorized this component value. It's established 0% here. It still reads 5% here. I remove the capacitor, and that's my reference capacitor, and it's gone to 0 reading here, and it's giving me an overload on the percentage. So in other words, an invalid reading. Now let me try capacitor number 2. So those went in. This is reading a minus 0.2%, and it's giving 5 bars down here. Let me try the next one. This is ostensibly the same value of part. Come on, go in there. Ah, you bugger. This one's going to need some help. Okay, that one was actually pretty difficult. This one's reading minus 1.1%. It's still giving me 5 here. Now we're going to get one that's way off the mark. Instead of being a 0.22 nanofarad part, this one's a 0.01. And this would be exactly the kind of thing you're doing when you're going through a bunch of parts, either sorting them or checking to see if they're all roughly the same value. So let me, this one's going to need help too. Okay. Since these are pretty stiff leads, I'm just holding the component in place. And it's registering a, well, this says 10 nanofarad part. I'm sorry, yeah. It is. It's a 0.01 microfarad part. These other ones were 0.022. So, yeah. It's 22 nanofarads versus 10 nanofarads. So I'm holding that, and now it's a minus 53% deviation. Oops, my component's slipping out of place here. Okay, I managed to get it to go in. So, a minus 53% deviation, which is not exactly what it says here. It says, well, that's 50, so it's like a 48% something or another. It's reading 48 against the 53.7, and it is not indicating anywhere that I can see that this is a negative value. So I'm not sure what you're supposed to do with that bar graph. I'm going to have to go back to Extech and see if they can explain that a little bit. Okay, and now for checking and hopefully demonstrating the sorting function. The manual is very clear that I can't have it in auto LCR mode for this. I need to push the LCR button until it says something else, and since I'm testing capacitors, I need to push it until it says auto without the LCR, and that it says that would be for inductance over here, and that's for capacitance. If I was doing resistance, I'd push that and it'd be resistance. So that's where it tells you. And then the next thing, it takes the auto away. Now it's DCR. If I push the button again, it takes me back to auto LCR. I don't want that. Push it once more to auto LP. Once more to auto CP, so I think that's as close as I'm going to get. And I've already got the frequency at 1 kilohertz where I want it. Now the instructions say to put in the reference capacitor. Okay, the reference capacitor is plugged in, and this one's been reading between 22.22 and 22.24. Now it's at 22.24. So according to the manual here, I have to push the sort button to establish this as the reference. The main display should indicate pass, and the lower display will indicate the value of the component. So right now the value of the component is up here. When I push it, it should shift down to here and it should say pass. So I'm going to push the sort button. Okay. There, okay. A temporary push. So it moved the component value down to here and chopped off 1 decimal point of resolution. And it has a total here, plus or minus, and it's still reading out the value here. Okay, so far so good. The default sorting percentage is plus or minus 1%. Okay, that's what that means. Gosh, I wish I could get rid of this light. So that that doesn't mean total, that means tolerance. So right now it's defaulting to a plus or minus 1% tolerance. And I know from my earlier experiments with the relative percent function that I had some parts that were more than 1% out. Yeah, one of them was 1.8% out. So let's look through the different tolerances here. I also had some that were only 0.4% out. So I can push the, let's see, which button does that. And it says, by the way, that if the reference value is above 2,000 counts or below 200 counts, the sort will not work. Well, I'm at 22 counts right now, so what's that mean? I don't know what they mean by counts here. So push the setup button in sequence to change the range, reference value, and the percent tolerance. So I push the setup button here once, and it goes to range. Push it again. Well, it's just sitting there in range. I guess it requires me to actually set something. So I have to push the left and right buttons to change that to something. I don't know what the range is. Let's see here. What if I push it to the left once? Oh, okay, it's changing the range of the component. Nanofarads, picofarads. Okay, yeah, it's 222, so I guess it's saying it needs to be below 202,000 counts, so I need to make sure that this is above 200 counts. So I pushed the right button until the decimal point disappeared. Now it's looking as the value is 200 I don't know what the heck that means. It's saying 222 nanofarads, but that's not true. It's not. It's 22.2 nanofarads. So I'm moving it back to here, and I'm pushing enter. Okay, and now, what's it doing? Is this the value setting? It did take away range. Maybe that means it's the value. Okay, let's say I don't want to do anything with that, so I'm just going to push enter. And now it's flashing the tolerance here. And I want to change it from 1% to 0.5%. So I'm going to push the left and right buttons until it goes to 0.5%. There we go. It could be 0.5%, 1/4%, or I can go up 1%, 2%, 5, 10, 20, etc. But I want to go for 0.5%. Okay, so I've got 0.5%, and then I guess I push enter to establish that. So I do that. Okay, so now it's back in pass mode. What happens if I plug in, and this is still with my reference capacitor here. If I take that out, it should clear that. It says fail because nothing's plugged in. Let's plug in this next capacitor. Okay, this one here is the one that was 22.1, so it's a minus 4% tolerance based on my past test. And I'm looking as it has to be within 0.5 or 0.5%, and since it's 0.4% out, it passes the component. And it's still reading 22.1, so that's roughly the value I had before. It was actually 22.16. It's lobbed off the last digit and apparently not rounded it. Let's try the next capacitor. Okay, this is the one that was 22.66 before. It's lobbed it off. It's reading 22.6. That was a 1.8% deviation, and that's why it's saying failure, because it's far outside the 0.5% tolerance I've stipulated. So that worked. And finally, let me put in the fourth capacitor. Okay, the last capacitor is in. This is one that was measured before as 22.01. It's reading 22.0 here, once again, because it's lobbed off the least significant digit of resolution. But that's a 1% or a minus 1% tolerance, which is outside of the 0.5% I've stipulated, so it fails this part. And I'm going to go, just for yucks, I'm going to put the original part back in. See if I can, by any chance, luck out and get it to go in without a lot of fuss. Doesn't look like it. Okay, got the reference capacitor back in. It's still reading 22.2 something, and it's well within the tolerance, being a 0% deviation, and it's giving me the pass. Now it's interesting that it does not tell me here what the actual deviation is. It's just saying it's passed or it's failed. It would have been nice with the bar graph that if they used the bar graph to indicate the percentage, that would have been nice, but it's completely turned off in this mode. But it does look like this function works. The only thing that's not really clear to me is the fine points of setting up the parameters. What I think happens is you put in your reference capacitor, you push the sort button to enter that value as a reference value, and it memorizes that value, but then you can go in and you can change it to some other value. If you maybe you don't have, I'm thinking this is the case. Let's say you want to test for capacitors that are 22.23 nanofarads, but you don't actually have a 22.23 nanofarad part to use as a component to copy the parameters from. The instructions say that by just pushing the sort button there, it'll log that reference value into memory and use it as the base value. But if you don't have a component of that value, but you still need to test for it, maybe you already used up the one that had that exact value, you could go into here with the method I already showed, and you can go in and stipulate the range, and you can actually go through and by using the left, right, and the up and down buttons, you can step through the component value digit by digit and set it to whatever number you do want it to be. Maybe you put in a part that was 22.20 and you say, well, that's not quite close enough, so you go in and change the last digit to 3 from 0. So I guess that's what they're getting at. And that would be the range part and the value part of the setup. And then the remaining part of the setup is the tolerance setting, which I think is the only part of the setup you need to do if you already set the values using a reference component. So I think the instructions could be better written there, but it does seem to be working. I'm going to be revising my own operating instructions, or my own manual, to have slightly clearer text in that regard. But I think I've demonstrated that that functionality does work on this meter. Well, here's an example of canceling a function. I'm currently in the relative percent mode as indicated by the triangle up there and the fact that the lower readout is showing percent. I want to cancel that, so I'm just going to tap the rel button, or just push it and release it like that, beep. And I know that didn't show very well, but let's put it back into that mode. Oh, it's still doing this, whatever that means. Okay. For some reason, a really short tap put it in the flashing mode, and then a slightly longer tap put it in the go away entirely mode. So now if I push the rel button again, for 2 seconds it took to put it in the mode. Problem is trying to show the button and the display at the same time. So here's holding it for 2 seconds. Well, that time it worked. Every other time I tried it, holding it down did not work. Let's put it back into that mode. Hold it until it beeps. Now it's in our friendly triangle display mode, and just a brief press puts it in flash. A quick tap returns it to that mode. Okay. 1, 2, holding it. That's just totally the opposite of the results I got just a half an hour ago, so big head scratcher. I guess the roll up from that is push the darn button in whatever way you need to get the triangle to go away. That's the key. Don't worry about whether it's half a second or 1 second or 2 seconds. Experiment until it works.